All right, I think we're good to go. That was a little hiccup. Always fun dealing with computer problems right at the start of stream. That's just excellent. Okay, well, we got both of those open, didn't we? Yes, we did. Okay, let's hop in there. So there was something that I completely overlooked. I have been aware of it before, but for some reason, just completely overlooked it. So if we go into our browser here, open up the manual. You're not sharing the right. Where are you? Okay, yeah, different name today. So if we're sharing the manual here, and we go to this browser tab. So I'm not sure exactly where it is. Maybe it's on 16. 16 is here. Nope. Tips isn't here. Let me see. Yeah, here we go. All right, so we got some macro instructions that we completely overlooked. So like writing copy FM a whole bunch of times, you can repeat it. Copy 1, 2, 3, 4, 5, you can repeat it 5 times. And then we start at 1 and we step by 1. So that would be like 1, and then 1 plus 1 is 2, and then 2 plus 1 is 3, and then 3 plus 1 is 4. And so you can kind of write this code with this repetition. And then there's some other pieces, like we can abstract more than one block here. So like this is repeated 3 times, 0 by 5. So we kind of skipped over some really, really useful bits of code. I guess expansion. I think they're always available, but we just completely overlooked them. So we're going to take those into account as we come in here. So I think last time I talked about maybe having like 9 different X's all sending, but that's going to be a problem because we need to count in one iteration. We need to count how many are larger than 55. So we're going to have to start one. So we're going to link. We're going to build 2 different X's. This Exa will be the simple one. We'll start here because it'll be the simple one. We're going to go link 800, and then we've got to follow this map over here. So link 1 to the next node, link 3 over there to where our nerve is, and then we're just going to mark loop, jump loop, and so this is going to copy M to nerve. That's pretty much it. Copy M to nerve. That's pretty much it. Now we could do the counting. We could do the counting here if we wanted to, or we could do the counting here. Let's do the counting here because this X is going to be moving, and so while it's moving, we can do some work. So we can copy M to T, and we only need to know, right? To determine the value that should be written, count the number of values read that are greater than -55. So this is what we're going to do. We're going to use our new repeat. This is going to be 9 times for 9 different nodes that we have. What is... Gosh darn it. I think it's end. End, right? Yeah, that looks right. So 9 times we're going to copy to T. We're going to test. T is greater than -55, and we're gonna T jump, or I guess we're just gonna F jump. Can we do that? Can we do that? We can't jump back in. Buddy. Actually, no, this is perfect, because that's gonna give us a 0 or a 1. That's gonna give us a 0 or a 1. And then count the number of values that are greater, yeah. So then we just simply add I, T to X. We'll just do X to T. We'll store that into X. So at the beginning of each run, we'll copy 0 to X. Then we'll add that to X. So the way that's going to work is if it's less than 55, then we're going to get a 0. And so 0 plus x is going to be 0. If it's greater than 55, we're going to get a 1. And so that'll be a 1. We add 1. That's essentially counting the number that's greater than 55. It's kind of a cheap way to do it. We don't actually have to jump around. And then once that's done, once we've counted all of them, we need to multiply that count by 5 and then subtract 75. So we will mul I x times 5 into x, and we'll sub I x 75 into nerve, just like that. And that's it. That should be that. Over here, we're going to link -3, link -3. So link 800 puts us here, -3, and -3 puts us here. Then we're going to start our loop, which is going to be a very different loop. But basically, we are still going to do it 9 times. So we're going to use our fancy repetition so we don't have to write it a whole bunch. Now, even though we're copying this, like we're repeating it and we're not writing 9 versions of it, it's still actually counting up. Welcome back. You missed the technical difficulties. So exciting to watch as I couldn't speak. Let me just double check everything's still running. Everything's still running? Yeah, it seems all good. Okay, back to this. All right, so we are starting on this node, so we're gonna read. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. We're gonna end on this node just so we can. We have like a predictable. I mean, we could go this way, but then we have to go back and back. So if we go this route, we end up here, and we only have to move to reset ourselves. We only have to move a few times. So we are going to copy nerve to. One sec. I need to take care of this for my kiddo. Okay. Okay. Copy. We're gonna copy nerve to M. So that's gonna broadcast that over to our other. I just realized we need to switch it up quite a bit here. Yeah, we can't just repeat that 9 times. We're gonna do this 1, 2, 3 times. So we're gonna copy nerve to M, and then we're gonna link 1. Once we get to here, we're gonna copy link. We're only gonna do that twice. Once we get to here, we'll figure out how many times we need to repeat it. We're gonna copy nerve to M, and we're gonna link 3. So we're gonna copy nerve to M, and we're gonna link 3, which is gonna go this way and this way. So now we're sitting here. And rep. Okay, then we're just gonna copy nerve to M, link -1, copy nerve to M, link negative. No. Why did I say -1? Oh yeah, -1 puts us here, and then we're gonna copy nerve to M, and we're gonna link -3. Then we're gonna copy nerve to M, and we're gonna link -1, and we're gonna copy nerve to M, and we're gonna link 3. And then we're gonna copy nerve to M. Okay, so I just had an idea. If we take that off, that should put us here. Then we can do 3 times. That's not gonna work. Ignore that. Once we're here, we need to link -3, just like that. So that should get us 1 round. You can see that it expanded the code, so we still pay for it in size. We don't get it for free. It just saves us writing effort. So that one's broadcasting, and then we go over here, and this one should be ready to write to nerve. Yes. Okay, that looks good. Okay, so everything seems to be okay. Oh, we got a wrong value. We got a wrong value. Why did we get the wrong value though? That's gonna read twice. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 values. And greater than that are greater than -55. So if t is greater than -55, add that to x. We multiply it by 5, and then we subtract 75. Okay, interesting. So we got the wrong value in there. So let's run it again. This time we're gonna pop this one out so we can see what we're doing. We're gonna get to this point. Okay, so we've written 65, that's good. We've written 55. Okay, so the third one is the bad one. So we're gonna start over. We're gonna do 1, 2 rounds. Okay. So we copy 0. That's a 56. That's 0. That's a -73. That's a 0. That's a -47. That one's greater. What do we just write over? -59. That's a 0. That one's 1. So we've got 2. -66. Okay, that's 3. -43. -73. Then we add that in. We multiply x times 5, and we subtract 75. And we wrote -55, and we needed -50. What is, okay, sorry, I'm having a hard time following this here. Okay, so the values that we have -56 that we're waiting to copy. -56 that we're waiting to copy. So all of these values are there. So we've got, that one's not correct. Where did that -56 come from? Okay, it is reading directly from nerve. So we've got, that's less than 1, 2, 3, 4. 4. So 4 times 5. Gotta pull up the trusty calculator here. Okay, so 4 times 5, that's 20, right? And then -75 is -55. So what, we must be doing something wrong on the read run, because the math checks out. Everything seems to check out with that one. So how are we looking on the read? We go here, we read 70, we read -67, we read -68, -58, -75, and then we go here and we read -70, but everything just changed. It just so happens, okay, I think I see what's going on. So we need to wait here, and then once we write to nerve, we need to copy that value in. So what's happening is we're reading the old value of nerve. So until it gets written, you'll notice once this one executes the write here, so right here, after that, and we see that all these values are going to change. Boom, they all changed. So we were reading that -70 before they changed. So now we tell it to start over, and it reads all the new values. So we should be good now. And we're looking a lot better. And we did it. Okay, yeah. Ooh, our network size is huge. So I'm really curious. Our size is large. I'm really curious how we do that with less code. Currently 306. Currently, so we could probably, whoops. The last time you'll have to hack yourself like this before I die. I was just thinking it'd be nice if you didn't have to constantly repair yourself. Now remember, the main character has a disease called the phage in the game, which is terminal, I would imagine. And so that's why you have to hack your body. That's what you need the medicine for, which is what we're after. We haven't encountered that part yet, but yeah. Okay. I wanted to jump back in here because I had kind of an idea. So one of the things that we decided to do is we decided to put the processing on this one. But I'm thinking, let's create a new solution and let's try this one. Okay, so we're still gonna need 2. This time we're gonna read the same way, but we need to mark that as our loop, and then we need to jump loop. Okay, so here we're going to test. Well, I guess at the start we'll copy 0 to x. We're gonna test nerve is greater than -55, and then we're gonna add IXTX. We're gonna rep that 2 times. And then we link 1. And then 2 times we're gonna test nerve greater than -55. Add IXTX. We're gonna link 3. And this is where we get to the end down here, where we just have test nerve greater than -55, add IXTX, link. So I'm even wondering, do we, like, could we do it differently? Like, all we need, yeah, that's fine, because if we copy it into a file, it's going to be the same either way. We link, we're at that last node. We need to link -1, and I'm going to copy this block because we're going to do yeah, we link -1, then we link -3, then we link -1 again, then we link 3, and then we copy, followed by the 2 -3s. Now, before we do that, we can go ahead and copy x to m, and then here we can void m. And then down here, it's going to be a lot easier. We're going to link 800, link 1, link 3. We'll simply mark our loop, jump loop, keep putting that code over. And I realize that I am underneath this block. Okay. Or the block was underneath my head. Okay. So we're going to do, we're going to get the count now. So we're just going to copy the count. We don't even need to copy it. We just need to multiply the count that comes in by 5, and then we're going to sub I x by 75, and we're going to write that to nerve, and then we're going to copy, because it doesn't matter what we copy, to tell it to go again. Okay. So that, and we immediately got the wrong answer. Okay, what happened there? Why did we get the wrong answer? The reason we got the wrong answer, copy. Test nerve is greater than 55. It's not. It's not. It's not. It's not. It's not. It is. So that's one. It's not. Ooh, we missed. Yeah, we missed. Where are we going? Link -1. Right here. Okay, we should be here. Link -1. Link -3. Link -1. We need to link 3. Yeah. There we go. Boom. Okay, so our size went down. Our activity went up a little bit. Oh wait, no, we're 302. Went down barely. Our size went down, and our cycles stayed the same. Okay. That feels like a useless refactor then, but I mean, I think we did well. Okay, let's meet with Ghast. Speak with your old friend about the present and the future.
Hanging in there? I just wanted to check up on you.
Checking up.
No, it's gonna be a while before.
No new zine. I don't think there's ever an issue 3, so we've got all of the.
Honest, it's getting harder for me
to concentrate.
Well, I just hope I was able to educate, give them
What?
some power. Otherwise,
Does he have the phage too? I don't remember.
They're gonna run right.
He's got a little Exa button.
Soon. Listen.
Depressed himself. That's not good.
We had some good times.
Of course we did.
I'm gonna go see you around somewhere. I'm out.
Yep. All right. See you later, Ghast. Will this be the last time I see him? Yeah, that didn't sound good. Something's going on with Ghast there. We did. Okay. Nevus D has connected. Okay. I'm trying to read old messages. Neva said, hello. So I'm new to this. Been trying to teach myself. You're in the right place. I'll probably lurk for a bit. We're all friendly here, more or less, except X10. Hydroponics, so I tried to get the go to last stop and it was all closed down. Anyone know what's up with that? They were caught refining nuclear material, so we did report them. It's kind of a big story. All right, Holman Dynamics. Retrieve credit card numbers from a supercomputer company's sales system. The data phones were cute, but I still need more computing power. We need to get some significant hardware upgrades. Of course, we're going to buy a supercomputer with credit cards. Specifically, credit cards that were used to buy supercomputers before. It'll be less suspicious that way. Someone who buys one supercomputer will buy 2 supercomputers, right? Yeah, that makes sense. Okay, got a big block there. Create a file in your host containing the contiguous 16-value sequence from the garbage file, file 199, that is a valid credit card number. There will be exactly one such sequence. How to validate credit card numbers. Okay. How do we validate credit card numbers? That is going to be in the second issue of the zine, which is page 26. So let's scroll down to page 26. Somewhere down here. Okay, here we are. Okay, so here's a breakdown. If you've ever messed around with credit cards, you know that you can't just make up any number and have it be accepted. In this article, I will present the method used by all major credit cards. To validate a number, start by summing all 16 digits from left to right. For the even digits and add the digit as is. But for odd digits, you need to double the digit and subtract 9 if it's greater than 9 before adding it to the sum. If the last digit of the sum is 0, which means the number is evenly divisible by 10, it's a valid credit card. Why is it designed this way? Beats me. Yeah, so interesting. All right, so it's gonna be 16 digits long. We know that. So the first thing we're gonna need to do is we're gonna need to find the garbage file. Do we know where it's at? Create a file in your host containing in the garbage file 199 that is valid. So it's on garbage. So it looks like we can just predictably go there. So we're gonna link 800, we're gonna link 802, we're gonna link 799. Okay. I'm gonna go ahead and create a second exa here because we're just gonna, this is gonna be our validator. We're gonna make, and we're gonna mark loop. It's gonna be our main loop here. Just gonna put that jump in there, make it a loop. So we're gonna validate numbers. We're gonna get the numbers from remote. So we're gonna copy. We're gonna copy m to x. We're gonna test x equals -1. Well, it'll be -9999. If it's -9999, then we are done. So we will mark, we'll t-jump validate. And then down here, we'll mark validate. So to validate it, we will seek -99. First, we need to count how many there are, basically. So we'll count it up. So x, copy 0 to x, mark C loop. It's going to be our count loop. Test EOF, t-jump, continue validation. And if not, we're going to add I1 to x, x1 to x. We will then jump C loop, right? Okay, so we need to test x is 16, because if it's not 16, we're gonna invalid. And we will, if it's not valid, we're done. If it is valid, I mean, if it is 16, we need to start doing the math. So we'll copy 0 to x, and we need to sum it. So we need to do yeah, we need all these values here. But we only have 2 registers. That's the tough part. 1, 2, 3. So 3 is going to be the only numbers that are like 0 to 3 are the only ones that we can double. Oh no, we're doubling. So that's 4. So 0 to 4 are the only numbers we can double without going over 10. Oh, then we need to subtract 9. So if we doubled 10 and we subtract 9, that's 1. If we doubled 6, that's 12. We subtract 9, that would be a 3. But if we doubled 4, that would be an 8. Yeah, I'm trying to think of a way, like if there's a way to do it. Could we get away with, I just want to test this, could we get away with like kind of cheating it like we did? Well, it's not really cheating it, it's just being creative. If we copy -10 into x, and then we, let's just say we have a file, right? And that file has the number 4 in it. And then we'll seek back to the beginning. Okay. Now we're going to mul I f by 2 into t. Yeah, okay. That didn't work. That's not going to work. Why are you not? Do I have an error? I do have an error. Okay, so we just need to mark invalid. And t-jump is TJMP. Okay. I have the browser open. Goodness gracious. All right, well, you haven't missed a whole bunch. I've just been fiddling with some logic here. Mul I F2T. Okay. Now we can do, okay, copy that, seek a -1, and then we subtract, yeah, I don't think that's gonna work. I was gonna say we can subtract 10 from it, or we can start it from -10, but multiplying it in place like that is just gonna be tough. So I wonder if we have another exa that does the validation and we just send the numbers to it, then we can simply send the value and it can write it itself. Okay, that's probably what we're gonna do. So our validate will be like another exa, and then we'll get a thing from there. So we do still need to kind of do all of that, but instead of here, we're gonna REPL tjump run validation. Okay, and then we'll swap modes. Well, actually, that one's gonna need to be a local, so we're gonna swap modes. We're gonna run validation. That's going to lost my train of thought. Okay, we're gonna run validation. We swap modes. We're gonna run validation, and then for 16 tries, you know what? We actually can do the count before we do all that. Let's do the count, because that's gonna be okay. Now we can if x is 16. Okay, now we can tjump run validation. Run validation. Okay. And then if it's not valid, we're gonna wipe the file. We're gonna make a new one, and we need to tell the other node, which is going to be waiting on us, that it was not valid. And okay, and then here we're going to mark run validation, and we'll mark valid number. Okay, so we're going to swap modes. We're going to REPL valid number, and then 16 times we're gonna copy. We need to seek to the beginning. Seek to the beginning of the file. We're gonna copy F to M, and then we're gonna copy M to T, where we're gonna tjump. If it's true, tjump valid. Otherwise, we're gonna go straight into it being invalid, which is where we let's do mark invalid. We're gonna fjump invalid. I realize we probably need an extra escape hatch, so we probably need, I don't see any negative numbers in here. So if it's -1, then we validate. If it's -2, we conclude. Otherwise, we copy X to F. And mark, I don't know why I called it conclude. We're just gonna call it halt. It doesn't need to do anything special. Okay. Tjump valid. Mark valid. Actually, if we just F jump invalid, we can go straight into validation here. So if it is valid, we've got the right card. We need to copy 1 to M and then jump halt. So we don't need valid. Goodness gracious. Okay. Valid number. Okay, so this is what we've repled here. Invalid needs to put us back in. Yeah, we're gonna swap back those here. Okay. Validate. So this is our little exit running. So it's gonna make a new file. It's gonna copy 16 times. It's gonna copy M to F, and then it will do the addition. So actually, we want to do 8 times. We want to copy F to M, and then we want to copy. We want to mul I F times 2 to M. And so 16 times, we want to copy M to F, copy M to X, test X is greater than 9. Then we want to if it's greater than 9, then we want to mul I T times 9, and then we can sub I X T into F. Okay. Yeah. So what we're doing there is, again, this is going to produce a 0 or a 1. If it's 0, it means we're not greater than 9, so we don't want to subtract 9. So we multiply 9 by that result. So if it's 1, it'll be 9, and then we'll subtract 9. If it's 0, it'll be 0, we'll subtract 0. So if we get an 8, that's less than 9, so it'll be 0. Then when you have 8 minus 0, if it's 10, that's greater than 9, it'll be a 1, so that'll be 10 minus 9, and we'll write a 1. Once that's done, we need to sum all the numbers. And we're going to rep 16 again, because we're just going to add. Do we need to do? Yeah, because we need to copy 0x. And we're going to add I xf into x. Boom. And we can actually add I ff into x. Then we only need to do that 14 times. We've already read from it twice. We don't have to copy into x. It's kind of a little shortcut that we've got there. Okay. Now, once we're at this point, we need to swizz x, where we only care about the first digit, and we want to test that x equals 0. T-jump number valid. Okay, and then we're going to copy 0 to M if it's not, and then we'll halt. I'm going to put a wipe here just in case we need it, and then mark number valid. Okay, wipe, halt. That's fine. Mark number valid. We're going to copy 1 to M. Okay, so that should be that. That should be that node. That takes up basically the whole program. So that's not ideal, because I don't know how much code we're gonna need here. Probably not that much. We're gonna we've already linked there. We're gonna mark loop, jump loop. We need to grab 199. Okay, so first test EOF t-jump conclude. We'll say end. Mark end is gonna, we have to copy -2 to M. Okay. If it's not the end of the file, we're going to copy F to M. copy F to M. We're not getting a continuation every time, so we need to copy F to X, test X equals negative 9999. If it does equal negative 999, we're going to copy negative 1 to M. Sorry. F jump right. So down here, we've got to mark right. We're going to copy X to M. And then, yeah, that copies negative 1 to M, which means to validate. So we're going to copy M to T, and we're going to T jump loop, or we will, all right, negative 1. If we get a negative 1 back, sorry. If we get a 1 back, we're continuing. If we're not getting 1 back, then we jump halt, which I will mark halt down here. Copy M, X to M, and then we'll jump loop. Yes, okay. Let's see if this works at all. Yeah, so we should be grabbing the file. Okay, so we're reading 1, 2, 3, 4, 5. Okay, we've read negative, yeah. So we copy negative 1 to M. This one has read negative 1. So it goes to validate. We count the number of items in the file. Why, oh. Okay. Yeah, we're just going. The count there, oh, we're over here. Okay, we need to pop you back over there. We have a bug, so in our count loop, yeah, because we just test EOF, we add 1 to X. We need to seek 1 as well. Okay, let's pop that back out. Okay. So let's get to this point where we send 1 over. It goes into count. We are counting the number of numbers in the file. We're at the end of the file. It says it's not 16. So it's invalid. We wipe the file. We make a new file. We copy back over here. Okay. Yeah, it needs to F jump. Yeah, that's what I thought. Okay, let's get there. So it is now validating. Okay, so we need to pop this one out so we can keep track of both of them. Whoa. Wait, why did we wipe the file? We want to run to running validation, right? Yeah, we'll get here. Okay, so that's not. Don't T-jump. Oh, we have another bug where we're just bleeding straight in. Besides, internet keep running away from me. I'm doing great. How are you? Sorry, you're still having some internet issues. Yeah, I struggled with some technical difficulties right at the beginning of the stream, so I know how it is. Okay, we have another bug. If it is invalid, once we copy that over, we need to jump back to our main loop run. And then I don't think... okay. We want to jump straight to... here? Yeah, let's pop that back out. Okay. That one's going to read to us another number, so we should be getting a longer number this time. So we can jump to here. No, we can jump to here. There we go. So this number is, that's 4, 8, 12. Okay, this one's longer than 16. So we can jump over here. Boom. Yeah, so here we go again, where we're going to copy that over. We got the number 8. Okay. That's not close to being valid. That one's not close to being valid. Nope. 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 Wait, that's 4. That's 8. That's 12. Oh, that's so close. But that's not it. We do know about how long it should be. We should have 4 on the second row. There we go. That's 8, 12, 16. That's 16 numbers. Okay, so let's get in there. Let's get our validation. We're counting up. We're counting up. Let's get to the test. It is 16, so we're going to run the validator. We swap to local mode. We spawn our little number validator. Hello, number validator. Now we transmit the number over. So we've got 1724162. Okay. So that should be popping those numbers in. Boom. Why is that 0, 1? Okay. We're gonna assume, let me double check the logic. So the raw digits, so we need to double the first number. So yeah, okay, so this is definitely gonna be wrong. Let's pop this one back. Let's cancel that. So what we know is, I think I've got this backwards. So the first number needs to be doubled because it's odd, so it's 1 based. I made a dumb programming error where you assume that it's 0 based. 0 is an even number, so the first number is odd, and then the second number is even. So 1, 2, 3, 4, 5, 6. Okay. Now what we can do is, we know we want to get to run validation, so we can just jump straight there. Okay, popping that out. That's gonna spawn. We're gonna pop that one out, and then we're gonna get the numbers in. So let's get these numbers through. Come on, numbers, you can do it. Okay, now we're adding all of them together. We have a number 16. We should not have a number 16. Why do we have a number 16? We did it because we didn't update our logic, did we? We need to do the testing first. Yep, that's right. So we need to do our testing first. Then we copy M to F, just like that. Okay. Now we know we want to get here. So we copy all of the values in. Let's get to this point. This is where I want to be. Okay. Back to where we were. We are watching these two. So we're going to sum all of these numbers together. They're all single digit now. We take the last value. It's not valid. We copy 0 over. We wipe that file and we halt. This is invalid, so it tells the main runner that we're invalid, and we continue again. That one's going to be invalid. That one's going to be invalid. That one is going to be invalid. I didn't mean to jump that soon, but that's not promising. We must be doing something wrong. Let's get to here. And here. And here. Actually, wait a sec. It doesn't ever say, I made an assumption. Create a file in your host containing the contiguous 16 value sequence from the garbage file that is a valid credit card number. There will be exactly one such sequence. So I never said it. I mean, I made an assumption. Basically, it's a 16-digit number that we're trying to read from the garbage file. It does have to be contiguous, but it doesn't have to be 16 together. So let's look at the outputs, actually. That's going to tell us a lot, which is probably something we should have done. So it's going to be 8384. So we need to find where 8384 starts. Yeah, 8384. That's a 16-digit contiguous right there. 8384. Oh boy. Isn't that not fun? Is that not fun? So that means that we need to do a lot more with the reading. The reading needs to be more involved. Because 8384 doesn't start on a boundary either. Where was it? 8384, right? And then 7879, 787. Yeah. So it doesn't start on a boundary. It actually starts one digit after the boundary. So that means that any connected 16-digit number will be moving forward. So we need to keep track of where we're at in the file, and we need to keep track of how many numbers we've read up to a 9999. Once we read 16 numbers, we need to rewind and then send those 16 numbers over. And we need to do it in very little code, which is going to be tough. It is going to be tough because we already have a file. We can keep track of how many numbers we've read up to 9999, which is fine because we're just counting the numbers. So test EOF, that's fine. This is where we're going to change it. So we're going to test, actually, each round we're going to copy, not the beginning of, the beginning of the loop. Copy 0x. Okay, so we're gonna test f equals -9. No. This needs to be at the beginning of a run. So we know we're gonna start. Oh, we'll figure that out. Okay, we'll figure out where we do that. Okay. Test f equals -9999. If it does equal that, tjump transmit. That can do the test for transmitting. If we're not transmitting the number, then we simply add I x1x. And kind of don't do anything else, right? Because we need to read up to 16. Okay, so once we read, so then at transmit, let's get rid of this. Once we're at the transmit, we need to seek back 16. Oh, test x equals 16. Because if it doesn't, we're gonna restart. Mark restart. We need to copy 0x, and we need to seek back x. Basically, we just read 15 values. this is going to be a little bit more difficult. So what we want to do is, if we've gotten to a 9999 and we don't have 16 numbers, we simply continue. But if we have, yeah, so I guess if we do test, so if x is less than 16, wait a sec. We hit negative 9999. Let's stop thinking. Okay. I'm trying to think about too many cases at once here. Yeah, no worries. I record the VODs for later. Okay, so what am I thinking? All right, we're going to try to read 16 numbers. We need to know when we hit negative 999, we need to know if we've read 16 numbers. So, like, this really needs to be like test continue, right? If we haven't hit negative 999, we add 1. We need to test if we've read 16 numbers. If we have read 16 numbers, we need to transmit them. Transmit. Okay, so transmit T-jump loop. Yeah, so if we haven't done either of those. Now, and what does n need to do? Mark n needs to copy 0. Mark n copy negative 2 to m, I think. Okay. T jump loop. Yeah, we'll update the code over there in a little bit because we're going to change the way that it receives. Right now, it receives every number until a 9999, but what it's going to do is it's going to receive a negative 2 to quit or negative 1. Actually, we don't even need a negative 1. We're going to receive true or false, and that'll jump to read a number or basically just kind of reloop. So if it's true, we'll read a number. Does it even need? Yeah, we do need a signal. So we're going to send... False means done, right? If it's false, we're done. Okay, so mark test continue. Continue or transmit if we're at 16. Actually, we should test that first. So can we test that first? Okay, we add 1 to x. Yeah, because if it's 9999, we're done. Yeah, okay, so mark test continue. If x equals 16. Wait a sec. This is this part. Like mark test transmit. And then here we just test transmit. Oh, continue. Yeah. Yeah, it's different. It's subtle, but it's different because mark x equals, not mark, test x equals 16, t jump to transmit. If it's not 16, we need to copy 0 into x and jump back to loop. That's why it's different. And then our transmit, it knows that it's 16 at this point, so it simply seeks back 16 from where we're at. And then 16 times, we're going to copy F to M. And then we're going to copy M to T. And we're going to T jump. If it's true, we are done. And if it's false, we copy 0 to X and we jump loop. Right, so we need a halt down here. Just like that, and we are over our limit. Okay, so I mentioned that this is going to change. So we don't need C loop anymore. We don't need a count. We already know the numbers that we're getting. And here we go. So we're gonna copy M to T. T jump, read, validate. F jump, if it's false, we halt. And actually, I don't want to wipe on halt because we need that file. Okay. So read, validate is I guess this is at the point that we'll make a file. We can make a file now, and 16 times 8 times 16 times we can copy M to this is good. Okay, because we can double up what we're gonna do. That's too many mode switches. I want to go ahead and spawn the validate so we can like read the number, transmit it, but I'm hesitant to do that. Because we'll just do it this way. We'll make the file, and then 16 times we'll copy M to F. Okay, so we've copied the whole code. Now we want to transmit over to our little one. So we're gonna swap modes. We're gonna REPL, validate. Let's just get rid of most of this. Most of it's gonna stay probably the same, but it's gonna change enough to where I just want to start fresh. So when we're validating the number, we are gonna we'll just receive the number, like, so we can just, no need to make a file. 16 times we're gonna add I M X M X. And we're a brand new node, so we don't even need to worry about all of that. We can swizz, that's an end. Swizz X1 to T, and then this one's done. Like, that's it. That's all it needs to do. Because what we'll do here is we'll REPL validate number, and then 8 times we will seek to the beginning of the file. We're going to copy F to X. We'll mul I X times 2, F times 2 into X. We'll test X is greater than 9 or 10. No, yeah, 9, because we need 10 or greater. And we'll mul I T times 9. We'll sub I T, sorry, X by T into M. And then we'll copy F to M. Okay, so we're gonna still do that, but we've moved where we do the math. And then we will copy M to T, and we'll T jump if it's true. Actually, if it's false 0, that means it was valid. If it was invalid, we copy 0. We switch back modes. If it was invalid, we copy 0 to M. And we jump loop. We also need to wipe. If it was valid, we copy 1 to M. Yeah, we copy 1 to M, and then we jump halt. Copy 1 to M, jump halt. I think we're good. Okay, so reading is a little more involved now, but we'll see if it works. So basically we need to keep reading until we've read 16 values. We're gonna hit -999 here. So that test, if it's, we jump to transmit, we copy 0x, and we jump back to loop. So here we are. We are counting again numbers. So as soon as we read 16, which I think we're about to do it, 14, 15, 16. Okay. We are now copying over here. We've made a file. We are receiving all of the numbers. We are missing one. I think we need to rewind 17. Nope. Copy 16. Okay, I took a screenshot. That works. Watch out, guys. Oh, hey. You should be writing this code. Let's see. We are... forgot what we're doing. All right. We get here. We transmit. We do transmit that 8. Ah, that's what we're missing. We are copying 1 to M. Yes, we're saying go for it. So we need to get here. We copy that 1 over. Now it starts reading. Okay, we get our 16-digit number. That's our probable credit card. Then we start writing that over to our second node. Simply just adding these numbers together. Boom, boom, boom. And it's out of instructions, and it dies, and we're waiting on it. Okay. What did we do wrong? That piece of code is supposed to T, to M, you dolt. Okay. Here we are. We are now swizzling 2 over here. So that jumps to, that copies 0 over here. Right, and so it copies 0 in. It copies 0 to X. Ooh, it shouldn't do that. It should copy 0 to X, but we should also seek 15 back, because we need to start back over where we were. Wait, not there. Here. Okay. No. Copy. Yeah. So now we've got this one. Boom. All right, it's waiting again. We wipe that out. Because we started at 8. So now we simply go through and we read the numbers again. So that's going to be 4, 8, 12, 16. So we are going to hit 16 again. So we can get to this point where yep. So now we're sending this next set of numbers over. It's doing the validation on them. Boom. And that was invalid. So we're continuing again. We go back. Something happened. We got a number, but it's not a valid number. What happened? Okay, let's test here. This one is very long. Yeah, that one's very long. That one's a little too long. So we're gonna get there. Okay. When I get back there, this number was, yeah, okay, that's good. We are waiting again. We have another set of 16 numbers. Now this one said they were valid though, right? And when they're not valid. Okay, so we've already got 8 in the register. I mean, how did we get 8 in the register? Nobody knows. That's 70? Is that 70? All right, let's add this up. All right, what do we got here? Let's see. We've got 10, so that's 1 plus 2 plus 14 minus 9 should be 3, right? What's going on? Why do I have 6? 5 plus. Okay, wait, what's going on? 5 plus, and then oh no, it's not 5 plus. Sorry, it's 10. So that's 1 plus 2 plus 14 minus 9 is 5. Right? Yeah. Okay. And then we do 3. And then 9. That's 18. Oh, that's going to be 9, right? Plus 4 plus 1 plus 9 plus 5 plus 9 plus 2 plus 6. That's 12, so that's 13. 8. That's 2. That's 71. Okay, so something is wrong in the validation math. I want to read. Yeah, this is going to be tough. I want to read up to this point where we start copying these numbers. Goodness gracious. Okay. I don't want to do. It's not the first one. It's not the second one. This one. Okay. So let's get that. As soon as that pops off, it's already spawned with X is 8. Aha. Okay, so we can cheat this a little bit. Well, we don't want to cheat it. But we need to add I 0M to X. I guess that's just copy M to X, really. Okay, and we want to get there. That's the first run. That's the second run. And that's the third run. Okay, now we have spawned this. It now copies the first value in. So we seek back, multiply by 2. It's greater than 9. So we send a 1 over, and it puts 1 in. 3, 8, 11, 20, 24, 25, 35, 44. We are going up to 62. I did something wrong. I did something wrong in my manual math, but yeah, okay, that's better. That's looking better. Let's get back to this point. We have another set of numbers. We get here. What value do we get back? Here, we've got a 0. Okay. We've got a 0. Goodness gracious. Got a 0. Okay, we are slowly making it through here. Ooh, we read through quite a bit. Is this our, this is not it. Here we go. We're reading through again. Is this, what's our target? 8384. And we're there. No, we're not there yet. We're not there yet. We got a 0 back. This should be it though. We did that. We did it. Okay. We are finishing them. This one's going to be slow, cycle count wise. This one's definitely going to be slow. Oh yeah, activity's good. Size is top of, wow. Cycle count, we're average. That's surprising. Our size is massive. I don't know how we could reduce our size. I mean, we could get rid of 16 commands here. Yeah, I mean, we could copy 16 into T. And then we could mark T loop, copy F to M, sub I T1T, T jump, T loop. And then once we exit the T loop, we do that. That's reduced our size. Where else do we have? So this one's 8 times, but we use T. So that's a problem. We could theoretically do it that way, but we use X. We use both X and T, which is problematic. This part, we don't use anything, so we could copy 16 into T, and then mark R loop, because we're reading, sub I T1T, T jump R loop. So that cuts our size quite a bit. We still have that. This one is 15 times, which we don't use T, so we could copy 15 into T, and we could mark V loop, sub I T1T, then we can T jump V loop. So that also cuts our size. Now I mean, our cycle count didn't get any better. Or maybe it did. Actually, no, it probably didn't, because we're doing a little bit more work. No, cycle count. Yeah, cycle count went up. Cycle count went up. Size went down considerably, like below average. All right. Yeah, cool. Didn't mean to do that. All right. Turns out you can order and take delivery of a supercomputer surprisingly fast. That's metaphor. That's use of metaphor. Very poetic. Thanks. Once this thing is fully online, it should be able to run dozens of metaphoric thought-space dimensions at once. That made words. Compete with an opponent to send your X's into the opponent's host. Okay, interesting. It's the final hacker battle. The final countdown. Be-do-do-do. Be-do-do-do-do. I hope that doesn't get a copyright strike. I made the noise myself. Are you nervous? Oh, yeah, because probably gonna bomb it, you know? That's some more positive encouragement for you. Okay, so this one. To win this battle, you must occupy a majority of hosts for as long as possible. You occupy... Goodness gracious, come on. Okay, you occupy a host if you have more X's in it than your opponent. Gain 1 point every cycle you occupy more hosts than your opponent. Lose 1 point every time we execute a kill command. Writing any value to the nuke register will destroy all X's in that host, including the X that triggered it. Okay. Writing any value to the nuke register will destroy all X's in that host. That's just downtown, yeah? So, what do we got here? We got 801, 802, 800, 800. This really seems like we just spawn them. Like, what do we got? Mark, loop. So first we link 800. And then, or I guess we got like spawn. We spawn, and then we like, so, no, mark loop, REPL jump. We'll REPL jump. So, I think 802 is the max. So 799, 800, 801, 802, that's 4. 4. REPL 4 times. Or repeat 4 times. We're going to copy. And then here we're going to start at 799. And we're going to go up by 1 each round. We're going to copy that into X. And we're going to REPL jump. Which I guess is just gonna be here, yeah. Spawn, right? Spawn. Oh no. Jump. All right. And spawn. We do that, and then we just kind of mark loop, jump, loop. We just kind of sit there and chill. And then here. This is spawn, mark, jump. We're gonna link X, jump, spawn, right? Yeah. How does that look? So they're going in and hitting nuke quite a bit. Why did I lose? Why did I lose a node here? Why did XA jump? Oh, because I didn't. Let's move this piece of code. Here. Actually, why am I doing that? Like, oh, we need jump. But this just needs to jump back to spawn. Like, spawn some more. We don't need this nonsense down here. Okay. So that's just spawning. So we're gonna keep spawning. We are losing our butts off. Why? We have hit 10. We have hit 10. We're 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 nodes. We've got 9 nodes. Yeah, we've got 9 nodes. So I think really we've got a size of 100. So if we link 800 with the main one, and then this one spawns, we really just need to send a node everywhere. So we will send mark highway. Highway is gonna link 801, and it's gonna copy 799 into X and REPL offshoot, I guess. REPL once. We'll do the mark loop, jump loop bit. So mark once just links 800 or links X, and then go straight into loop. And then you also need to REPL mark overpass. Okay, hang on a sec. We've got a couple different kind of nodes. We've got. Does the network change up? Oh. There's no way in there. There's no way in there. 801, 802. 801, 802. 799 and 800. But that's not 800, that's -1. That's 800. Okay, hang on. All right. 801, 800, right? And then here it's 801, 800. Okay. This one is 801, 800. Okay, so the network layout doesn't really change. And it doesn't look like the network IDs change either. Okay, so we have a few different kinds of nodes. We have a few different kinds of nodes that we are targeting. We are targeting these like side nodes here. This side node where we're like linking into it via and so we're gonna mark I'm gonna call them road. We're just gonna call them road. So it's gonna link X, which will get us there, and then it's going to copy 799 into X, REPL offshoot or REPL single, and then link copy 800X REPL 800. So single's just gonna link X and then jump loop. Mark loop, jump loop. Okay, since single's just gonna go straight in there, we're gonna do that. And then 800 her mark lone. That's a lone node. Copy 800 to X. And this one's going to singular. It needs a target. I need to give it a target node. So copy 800 to X and REPL single. Okay, so single's gonna link X. It's gonna REPL lone. It's gonna copy T to X and then REPL lone, jump, loop. And then you are gonna jump, loop. Okay. So you're a double. You're a double. Cool. So we're gonna spawn. We're gonna copy 800 into X, 801 into X, and we're gonna REPL double. Wait, what is that one? Copy 799 into T. And we're gonna REPL double. I think 799 can be in T. Either way, right? Then we're going to dang. Because then over here, I'm on the back road overpass. But it's the same either way. Okay. So we're going to call you left. That's right. We're going to call you right. Right. We're going to REPL right. So that's going to link 801 and it's going to do the single. Then we're going to copy 802 into X and we're going to REPL left. Now left is different. Left just goes to 800. So it's going to REPL double. It's going to REPL. It's going to copy 800 into X and 799 still into T. REPL double. Jump. Loop. So 800, boom. And then double already goes to 800. Yeah, copy single. Does that work? Spawn, we're gonna spawn the double, we're gonna spawn that. Then we're gonna mark S loop. And we're gonna jump S loop. So S loop is gonna be 800 into X. Mark nuke, or we're gonna REPL nuke, REPL occupy. This one will be mark nuke. It's gonna link 800, copy 1, nuke. Copy. That's gonna nuke it, and then occupy. Mark occupy will link 800. Jump loop. Let's see if that works. Okay. $801. We got a lot of folks sitting here on this node. Copy 801, REPL double. Double links X. It missed the loan. Oop. I feel like getting to those is going to be primary, so maybe we refocus here. So we'll REPL left, REPL right. Mark left, mark right. Okay, so left is going to link 800, link 802, link 800, link 799. Mark right is going to link 800, link 801, link 799. And then we'll have our loop where we just jump loop. And so you will jump loop. So that goes, they don't make it. How does neither one of them make it? That one's starting with 2 there. So let's copy that. Let's copy that. We'll REPL right, and then we'll go left. That one made it. That one made it. But we want to link 800 first. Then we'll REPL right so we can get rid of that 800. Still didn't make it fast enough. Okay. He doesn't seem to beeline it there. Is it possible if I link 800, link 802, link 800, link 799, can I beat him if I just ran straight there? Yes, I could beat him. If I ran straight there, I could beat the opponent. How do I run straight there? So I think to run straight there, I literally just have one run straight there. Done. All right, this one needs to go there, and we'll REPL left. We don't need the right way anymore. And then for now, we'll just jump. We didn't make it. Why didn't we make it? Because we went left and not right. So you just go 801, 799. Wow, keep hitting escape too many times. You mark loop, jump loop. There we go. Okay, now we need, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to gain 1 point every cycle you occupy more hosts than your opponent. Yeah. So if I get these two, that sets me up to succeed. So then I just need to mark, let's see, right single. I'm gonna call it right single. Right side dominant. So we need to copy. It's 800. We're just doing 800. So we link X. Oh, why do I need link X? It's right side. We link here. It's double. They're both 800s. They're both 800s. How many? Okay, 1, 2, 3. I'm trying to count up how many nodes. 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10. Okay, we should be okay on size to do this. We need right needs to That's 3, 6, 7, 8, 9, 10. So Mark Wright is gonna link 801. Let's see, jump or Mark take, I guess. Link X, REPL, copy 800 into X, REPL take, jump loop. So we want to link 800. We want to copy we want to REPL right single. We want to copy 801 into X, and we want to mark jump REPL take. We want to copy 802 into X. We are going to repeat that. We want to copy. We want to start at 800. We're going to go up by 1. No, we want to start at 801. And then we're going to REPL take. And then we're going to nuke. So we're going to jump into nuke loop. We don't need that. We're going to mark in loop where we REPL nuke. Mark nuke is going to link 800, copy 1. Okay. Wait. Oh, into X, yeah. Boom. We are taking nodes. Oh, somebody lost. Jump loop. Why did that one lose? Jump loop. Why did we lose? Why are we losing 19? Okay, 2 0. 2 0. Copy 800 into X, REPL take. We are at size. We are at the size limit, which is fine. We're at the size limit. But we hold every host. Is it gonna hold up? We lost 4 times. I'm gonna take it. I'm gonna take it. Oh, I didn't mean to continue editing. Oh, this is a little group. Yeah. That's a great accomplishment. You're one of the best at what you do. All right. Well, I'm the best fake hacker in this game. Sweet. Okay, what do we got here? Maybe I should change my name. Why? Why do you have that equal sign anyways? I always wondered. I was drunk when I signed up. It was just a typo. I was describing myself. Let's see. Oh, got me too. That's some nice exit programming there. Good to have you back, Moss. Even though you don't say anything, it's fine. I get it. Moss, huh? Never mind. So Nevus recognizes. All right, we're meeting with Ember 2's newfound. Discuss Ember 2's
computing power. Is it feeling good?
Oh, we got a voice.
Feels the same. I'm handling a lot more information now.
A lot more information.
It's progress at least.
Yep. Progress towards what?
All the data I've gathered. Why is the world the way it is? Why does
Why?
It
That's a good question.
I have a theory. A good one. I'm not going to tell you what it is yet.
Okay. She has a theory, but she's not going to tell us what it is. That's great. All right. We've got access a governmental DNA database and overwrite one entry with another. Oh boy. That's always a good thing to get into. How do you think people would react if they knew their elected officials didn't represent their interests? I think most people already feel that way. That's the subject of our experiment today. We're going to make people believe their leaders are genetic clones of each other. It takes a certain amount of courage, Good thing there's a centralized government DNA database. I wonder who thought that was a good idea. You plant the evidence, I'll take care of the rest. Okay, look at that. FEMA, genetic database. Okay, override the genetic sequence of Senator Walker Kane Jr. with the genetic sequence of President Walker Kane so that it looks like the younger politician is actually a clone of the older. So it looks like we need to find... what do we have to do? The names of 2 politicians are available in file 300. Note that you may need to overwrite a data chunk with another data chunk from the same file. Okay. For more information, see accessing data in legacy storage systems. Okay. Well, we've got 10 minutes left, and this one's definitely going to be a doozy. So I think we'll just stop it early today. Unless folks are just dying to see us continue. Yeah, we can start looking through this. I'm gonna go ahead and pop open the browser so we can see what we're doing. Of course, it has a different name now. Okay, it did show up. Okay, good. Let's start reading the legacy system piece. So storing data in legacy systems. Is that in the first issue of the zine? I was already in the right place. Storing data, accessing data in legacy systems is on 26. 26, where are you at 26? Here we are. Tape storage systems. Each tape contains 0 or more backup entries. Metadata for the entries is stored at the end of the file in 3-value triplets. So it actually looks like the sequence is pretty long. Right, like look at this. 528, 313, 143, 317, 127, 511, 433, 530. These are all files with the whole sequence. These are all files with the whole sequence. So 528 would be 805, and there is no 28. What does 528 mean? Maybe we should read this. To get the data for an entry with metadata secret 34, you'd go to the beginning of the file, skip the first 3 values, and then read off the next 4 values. Interesting. Okay. Hard drive arrays. Here we go. Hard drive arrays. Arrays of hard drives are still used today. The first file, 200, in the first drive should contain a table of all backup entries. So file 200, that's this one. Each entry consists of the entry's name, followed by the address of the chunks storing that entry's data. A chunk address is a number between 100 and 999 that points to a chunk located somewhere in the drive. It points to a chunk located somewhere in the drive array. The first digit indicates the drive that contains the chunk, 1 through 9. The second digit indicates the file that contains the chunk, 0 through 9. And the final digit indicates the location of the chunk within the target file, 0 through 9, mapping to offsets 0 through 90. For example, to retrieve chunk 527, you'd access drive 5, so that'd be 805, grab file 202, and then seek to offset 70 and read the next 10 values, the size of a chunk. Not so complex after all. Sure, not so complex after all. So, interestingly enough, we need to read these numbers So we need to find, let's try and get President Kane. So let's just grab 300, copy F to X. We're going to drop it. And then we need to go to link 800, link 801. That's the first drive. And grab 200. Then we need to test here. So we're going to mark search loop, test EOF. Well, we shouldn't hit the end of the file. Let's make an assumption that we're going to find who we're looking for. So we're not going to hit the end of the file. So if test equals there's 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers for each. Okay, so test F equals X. T jump found. If we didn't find, we simply seek 10 ahead and we jump search loop. We mark found. We want to REPL get files, and then we're gonna just do 10 times. So we're gonna copy 10 into T. We're trying to save space here with the code if we can, and we're gonna copy F to M sub I T1T, and then we're gonna T jump mark copy loop. We're gonna T-jump copy loop. When we're done copying, we're just gonna halt. That one will be done. All right, now get files. That needs to be a mark. We need to make a new file. We are going to 10 times. We're gonna copy 10 into T. We don't want to copy that in every loop. Okay, copy 10 into T, mark read loop. We're going to copy F, M to F, and we're going to sub I T1T. We're going to T jump read loop. When we're done reading, we're going to put a block in, -999, copy, -9999 to F. We're going to seek to the beginning of the file, and we're going to mark, and then we're going to link, well, I guess what we'll do, so link 800, link -1, okay, mark, build, code. Okay. So we should be back on the main strip. So we're gonna copy F to X. We're gonna test X equals -999. If it does, then we're done. T-jump, clone. Dang, yeah, dang. We got 150. Oh, cause we're just reading. Okay, let's go build the code. It's like, do I want to do this? Like, I want to find President Walker Kane, and I want to find Senator Walker Kane. And then I want to read their first files, and I want to read, it's like I want to spawn an exa for each chunk, because it's going to read a chunk of 10 and write a chunk of 10. So it needs to know the source chunk that's reading from and the source chunk it's writing to. So actually, I just want to grab 300. Link 800, link 801. Now we need to find their offsets within the file. So we want to find President Walker Kane's offset. So we want to copy F to X, seek -1. Then I have to drop it. Drop. Seek -1 void F. Let's delete it. And we will mark spawn loop or mark search loop. Mark search loop. It's not going to be into file. I want to search through the file to find President Walker Kane, and then I want to search through the file to find the other person. And I want to get their offsets so we can start spawning them. I think it should be fine. Let's copy -999 into F. We know how big this file's going to be. Okay, so mark search loop. Copy F to X. Seek to the end. Seek to the end. Seek to the... Oop, nope. Then we copy. Then we seek to the beginning. Then we drop it. Oh no. Yeah, then we test was X equal to this. If it was, we seek T jump spawn workers. If it's not, if it was not equal to -9999, what we're gonna do I feel like that's a lot of dropping. Okay, let's not worry about it. We'll worry about the code later. I'm getting ahead of myself in my head. That's how you know I'm tired. Do I still have the browser open? Where's OBS? Yes, I still have the browser open. Exhilarating content. It's getting bad, me forgetting that. Yeah, all right. So, spawn workers. Okay, if it's not equal to 999, we need to search for it. So we need to grab, we need to drop. We should already have it. Copy. Okay, if it's not, we're going to drop the file. We're just going to call it start loop because we need to search loop here. We are going to copy, because I need to know where in the file I'm at. I need to know where in the file I'm at. Goodness gracious. Okay, yeah, we're gonna stop here. This one's gonna be tough. I feel like we're gonna need some orchestration. Yeah, that's gonna be a good chunk of the next session. So I'll see everybody on Thursday. We'll pick right back up there, writing DNA sequences to the database. Thanks everybody who showed up, watched. I really appreciate you, and I'll see you on Thursday. Cheers, folks.